So now we have completed 4 of the 7 sections, and now we will do section 5, systems of linear equations in 2 variables. And we'll start with this theme, solving systems of linear equations. So what does a system of linear equations means really? So if you have a pair of linear equations in 2 variables, that is what we refer to as a system of linear equations. So let's take a look at an example here. So we have these 2 lines corresponding to these 2 equations, y minus x equal to 1 and 2x plus y equal to 4. So taken together as a pair of equations, we will refer to this pair as a system of 2 variable linear equations, and we will now learn how to solve a system of linear equations. So we're first talking about the graphical method in which you just look at the graph and you find the solution of the system. So what does the solution of a system really mean? So if you think about this line, y minus x equal to 1, all points on this line are solutions to this equation. And now if you take this line, which is 2x plus y equal to 4, all points on this line are solutions to this equation. And there is exactly one point, which is this intersection point over here, that lies on both this line, and therefore this point is a solution to both these equations, and therefore this point is the solution to the system of linear equations. And what is this point? This is the point 1, 2, as we can see from the coordinates. So this point, or these coordinates 1, 2, will satisfy both these equations, and therefore this is the solution to the system. So that is the graphical method, as simple as that. We just look at the graphs of the 2 lines of the system, we find their intersection point, and that intersection point is the solution to the system. Now let's talk about the substitution method, which is an algebraic approach to finding the solution to a system of linear equations. So we have this system which is 2x plus y equal to 4 and y minus x equal to 1, and we have to find the solution to this system using this substitution method. So what is this method? It's actually fairly simple. We take any of these equations and express one variable in terms of the other. So let's take this second equation, y minus x equal to 1, and now let's express y in terms of x. So I add x on both sides, so I'll get y is equal to x plus 1. So now I have expressed y in terms of x, and now I will substitute this into the first equation. So the first equation is 2x plus y equal to 4, and now instead of this y I will substitute x plus 1, which I got from the second equation. So that's the substitution that this name refers to. Alright, so 2x plus, instead of y I will write x plus 1, this is equal to 4, so this is 3x, and you subtract 1 on both sides, so you get 3x is equal to 3, which means that x is equal to 1. So you have obtained the x value of the solution now, x equal to 1. Now you can substitute this back into any of the 2 equations. So perhaps we can substitute this back into the second equation. So x is 1, so y minus 1 is 1, which means that y is equal to 2. So x equal to 1 and y equal to 2. So 1, 2, this is the solution to this system. So that is the substitution method. Take one equation, express one variable in terms of the other, substitute into the second equation, find the value of one of the variables, and then use that to find the value of the other variable. Now we'll talk about another algebraic approach to solving a system of linear equations, which is called the elimination method. So in this method, as the name suggests, you eliminate one of the 2 variables and find the value of the other variable. So here we have 2x plus y equal to 4 and y minus x equal to 1, and you can see that you have a positive y and a positive y in both on both the left sides. So how could I eliminate y from this pair of or this system of linear equations? So if I subtract from the first equation, if I subtract the second equation, y should get eliminated and I'll only be left with x, and therefore be able to find the value of x. So let's do that. So I have 2x plus y minus this left side, which is y minus x. So this is what I get on the left side, and on the right side I get 4 minus 1. Okay, so let's simplify this. So we get 2x plus y, and now open this parentheses, so minus y plus x is equal to 3. So these terms cancel out and we get 2x plus x, or 3x is equal to 3, and from here we conclude that x is equal to 1. So what has really happened here is that we have used these two equations. Specifically, we have subtracted from one equation the second equation and eliminated one of the variables, and we are only left with a single variable equation, 3x equal to 3. That gives us the value of that variable, x equal to 1, and once again we can substitute it back into any of the two equations to get the value of the other variable. In this case it will come out to be y equal to 2. So 1 comma 2 is the solution to this system. So that's the elimination method. In this case I eliminated y, but you could also have eliminated x. So let's see how we would do that. So our system is 2x plus y equal to 4, and then y minus x is equal to 1. So how would I eliminate x? For that, what we need to do is we observe that here we have a 2x, but here we have a negative x. So let's multiply both sides of this second equation by 2. So if I do that, so 2y minus 2x is equal to 2. And now if I add these two equations, these two terms will cancel each other out. So let's do that. So if I do that, if I add these two equations, so these two terms cancel out and I get 2y plus y, or 3y on the left side, and on the right side I should get 6. So 3y is 6. Once again I get a single variable equation from where I conclude that y is 2, and now I can use this in any of the original equations and find the value of x as 1, and once again I will get the solution as 1 comma 2. So that's the elimination method. You can eliminate either variable and find the other variable, and then use that to find the remaining variable as well. Now here's an SAT sampler on this theme of system of linear equations. If 3x plus 2y equal to 15 and x plus y equal to 10, so this pair is our system of linear equations, what is the value of x? So what this problem means is that this pair will have some solution, x comma y. What is the value of x which forms part of that solution? Okay, so how would you find the solution to this pair? You could do any of the ways we've learned, graphing, which would actually be cumbersome here, or you could do substitution, or you could do elimination. Remember, we only have to find the value of x. So the simplest possible approach here might be, let's just substitute, let's just write y in terms of x using one of the equations and substitute that back into the second equation. So let's do that. My first equation is 3x plus 2y equal to 15. And my second equation is x plus y equal to 10, and from this equation let me write y in terms of x. So subtract x on both sides, I get y equal to 10 minus x. So let's substitute that back into this first equation. So I get 3x plus twice of 10 minus x is equal to 15. So instead of y I will substitute 10 minus x. So let's do that, 10 minus x like this. So that's the substitution, and now let's simplify this. So get 3x plus open these parentheses, so we get 20 minus 2x is equal to 15. Okay, what do we have now? So 3x and negative 2x will combine to x, and then we can subtract 20 on both sides to get rid of this 20. So I'll get x is equal to 15 minus 20, which is negative 5. So x is negative 5 is part of the solution, but because we only need to find the value of x, we can actually stop here, and negative 5 is our answer. Now here's our next SAT sampler. We have this pair of linear equations, ax minus 4y equal to negative 10, bx plus 3y equal to negative 15. If the graphs of the lines in this system of equations intersect at negative 3, 1. So these two lines intersect at negative 3, 1. What is the value of b over a? Well, it's a very straightforward problem. If these two lines intersect at negative 3, 1, it means that this point or these coordinates are solutions to both these equations, and therefore their coordinates should satisfy both these equations. So that's all we need to do. Use these coordinates, substitute these coordinates back into these equations, and therefore find the value of a and b. So let's do that. So the first equation is a times x. Instead of x, I'll put minus 3, negative 3, minus 4y, and y is 1. So 4 times 1 is equal to negative 10. Alright, so let's simplify this. So I get negative 3a minus 4 is negative 10. Let's do balancing. So I add 4 on both sides. So that should give me negative 3a is equal to negative 6. And now we can divide both sides by negative 3. Okay, so that will give me a equal to 2. So a is equal to 2. And now let's find b. And for that, let's substitute these coordinates into the second equation. So the second equation is bx. So b times negative 3 plus 3y. So 3 times 1 is equal to negative 15. So let's simplify this now. We get negative 3b plus 3 is negative 15. Let's subtract 3 on both sides. So we get negative 3b is negative 18. And now let's divide both sides by negative 3. We will get b as 6. Alright, so a is 2 and b is 6. So b over a should be 6 over 2, that is 3. So C3 is the correct answer. Our next theme in this section is number of solutions of systems of linear equations. So let's start with this first case, which is the no solution case. What do we see here? So we have two lines and they seem to be parallel lines. In fact, they are, because their slopes are the same. This line has the equation y equal to 3 over 2x plus 3. So the slope is 3 over 2. And this line, the second line, has the equation y equal to 3 over 2x minus 2. So the slope here is again 3 over 2. And the y-intercepts are different. So this line has a y-intercept of 3, as we can see from this point here. And this line, the second line, has a y-intercept of negative 2, as we can see from this point over here. So these two lines are parallel to each other, which means they never intersect, which means that there's no point in the plane that lies on both these lines together. So there's no pair of xy values that will satisfy both these equations together. And that is why this is the no solution case. There is no solution to this system of linear equations. So whenever you have such a situation where you have two lines where the slopes, let's say these are the two lines in slope-intercept form, y is m1x plus b1, y is m2x plus b2. If m1 and m2 are equal, which means the lines have the same steepness, the same slope, and the y-intercepts are unequal, which means that they intersect the y-axis at different points, it means that they are parallel lines, different and parallel lines, and that means that the system will have no solution. So that's the first case. Now let's talk about this second scenario where we have infinitely many solutions of the system of equations. So we have two equations here, but we actually just see a single line in the graph. So what's going on? Let's try and understand this a little better. So one equation is 3x minus 2y equal to negative 6, and one equation is 6x minus 4y is negative 12. So let's first write both of these equations in the slope-intercept form. So in this case, I will isolate y and write it in terms of x. So I'll add 2y on both sides and then add 6 on both sides. So I'm doing two steps together. So I should get 2y is equal to 3x plus 6. And now let me divide both sides by y by 2, and that will give me y equal to 3 over 2x plus 3. Okay, so this first line has a slope of 3 over 2 and a y-intercept of 3. And yes, this line does indeed seem to have a y-intercept of 3. Now let's see what this second line, where the second line is. This actually, the equation seems to be different because we have here 3x minus 2y is negative 6, and here we have 6x minus 4y is negative 12. So the coefficients are different, but let's actually write this one as well in the slope-intercept form and see what this simplifies to. So once again, I'll add 4y on both sides and 12 on both sides and write this as 4y is 6x plus 12, and now divide both sides by 4. So that will give me y is 6 over 4x, which is 3 over 2x plus 12 over 4, which is 3. So what I'm getting as the slope intercept form of the second equation is exactly identical to the first one, which means that in effect this first equation and the second equation, they are essentially representing the same line, and therefore you are seeing two lines on top of each other, and therefore it appears as a single line. And that is why infinitely many solutions, because every point on one line also lies on the other line. So in a way, you can say that there are infinitely many points that lie on both the lines, because in effect they are the same line. So when does this case happen? So if you have two equations, let's say one of them is m1x plus b1, y is m1x plus b1, one of them is y is m2x plus b2. If the slopes of the two lines are the same, so m1 is equal to m2, and the y-intercepts are also the same, if b1 is also equal to b2. In such a scenario, these two lines are essentially identical, they're on top of each other, and that means that you will have infinitely many solutions. And now we come to the third and final case, which is the exactly one solution scenario. And here you see two lines. You have y minus x equal to 1, which is this line, and you have 2x plus y equal to 4, which is this line. And you can see that the slopes of the two lines are different, which means that they will intersect in exactly one point, which is this point here, the point 1, 2, which will be the solution to this system of linear equations. So when you have a scenario like this, where you have two lines of different slopes, you will always get exactly one solution. So what does that mean in terms of the slope intercept form? So if you have these two lines, there will be exactly one solution if the slopes are different. So if m1 and m2 are unequal, then it's guaranteed that you will get exactly one solution. It doesn't even matter what the y-intercepts are, because the slopes are different, they will intersect each other and you will get exactly one solution. Now here is an SAT sampler on this idea. We have this pair of equations. 5x minus 3y is 10, 6y is px minus 42. So this is a system of linear equations, and in this system p represents a constant. If the system has no solution, what is the value of 2p? So the system has no solution, which means these two lines should essentially be two parallel and different lines. So how do we ensure that, and therefore how do we find the value of 2p? Well, let's just write these two equations in the slope intercept form. So we take the first equation, 5x minus 3y equal to 10, and isolate y. So let me add 3y on both sides. So I should get 5x equal to 3y plus 10, and now subtract 10 on both sides. So I should get 5x minus 10 is equal to 3y, and now divide both sides by 3, and I'll write y on the left side. So 3y over y is over 3 is y is equal to 5 over 3x minus 10 over 3. Okay, so this is the slope intercept form of the first line. Now let's do the same for the second line. So we have the second line is 6y is px minus 42. All I need to do now is divide both sides by 6. So let's do that and write it over here. So divide both sides by 6. I will get y is p over 6x minus 42 over 6, which is minus 7. Okay, so now I observe that the first line has a slope of 5 over 3, the second line has a slope of p over 6, and their y-intercepts are different. So all I need to do is ensure that the slopes are equal. So 5 over 3 should be equal to p over 6. So let's multiply both sides by 6. So I will get 10 on the left side and p on the right side. So p's value is 10, which means 2p, the value we need to find is d 20, and that's it. Now in this next SAT sampler, we have this system of linear equations. 6x plus 3y is 18, kx minus y over 3 is n, In this system, k and n are constants. If the system has infinitely many solutions, what is the value of k? Okay, so when does a system have infinitely many solutions? When the two lines are identical, when their slopes and y-intercepts are the same. So that's what we need to ensure here. So we'll first write both of these equations in slope-intercept form, and then we will ensure that they represent the same line, or their slopes and y-intercepts are the same. So let's start with the first equation. 6x plus 3y is 18. So subtract 6x on both sides. We get 3y is negative 6x plus 18. Now divide both sides by 3. So you get y is negative 6 over 3, that's negative 2x, plus 18 over 3 is 6. Okay, so that's your first equation in slope-intercept form. Now let's do it for the second one. Let's first get rid of this 3 in the denominator, multiply both sides by 3. So we get 3kx minus y is 3n. Now add y on both sides. So you get 3kx is y plus 3n, and then now subtract 3 on both sides. So now you can write this as y is equal to 3kx minus 3n. So now you have written your two equations in slope-intercept form. You have y is negative 2x plus 6, and here you have y is 3kx minus 3n. And now for the system to have infinitely many solutions, you want the slopes of this system to be the same and the y-intercepts also to be the same. So for the slopes to be the same, negative 2 should be equal to 3k. So let's do that. Negative 2 should be equal to 3k. Divide both sides by 3. You get k as negative 2 by 3. So that's one piece of the puzzle. But in this problem, we only had to find the value of k. So if you want, you could stop here and just choose k as negative 2 over 3. So B would be the correct answer and everything else is incorrect. But in this, you also need to ensure, for completeness sake, that the y-intercepts are also the same. So you also want 6 and negative 3n to be equal. So 6 should be equal to negative 3n. Divide both sides by negative 3. You will get n as negative 2. So only if k is negative 2 by 3 and n is negative 2 will this system have infinitely many solutions. If n has any other value than negative 2, then this system would have no solution because the slopes would be the same, but the y-intercepts would be different. Anyway, in this problem, we were only asked to find the value of k. So we could stop at finding k and just picking B as the correct answer. Our last theme in this section is modeling real-world situations using systems of linear equations. And here is a nice SAT sampler on this theme. Restaurant P sells burgers for $2.20 per burger and bags of snacks for $1.95 per bag of snacks. Restaurant Q sells burgers for $3 and bags of snacks for $1.50. A certain purchase of burgers and snacks would cost $18.55 at restaurant P or $19.50 at restaurant Q. How many bags of snacks are in this purchase? So let's break down this problem and model it step by step. So the two unknowns here are in this certain purchase of burgers and snacks, how many burgers were purchased and how many snacks were purchased. So let's say the number of burgers purchased was X and the number of snacks purchased, let's say, was the bags of snacks was Y. Now we know that in restaurant P, the cost per burger is $2.20 and for X burgers, the cost would be 2.20 times X for the burgers, and for every bag of snacks, restaurant P charges $1.95. So for Y bags, the restaurant P would charge 1.95 times Y. So restaurant P would charge a total of this sum, 2.20x plus 1.95y, and we know that this is how much? So $18.55 at restaurant P. Okay, so this should be 18.55. So now you see that we have derived one of the two equations of the system that will system of equations that will apply here. Now let's do the same thing for restaurant Q. So for the same X burgers and Y bags of snacks, restaurant Q gets to a total of $19.50. So we should get $19.50 on the right side, 19.50, and on the left side, for the X burgers, we will have X times 3. So because the cost is $3 per burger, so 3.00x plus restaurant Q charges $1.50 for every bag of snacks. So that times Y would be 1.50y. So now we have this system of linear equations in X and Y, and all we need to do is solve this system and find the values of X and Y, and that would give us the number of burgers and the number of bags of snacks in this purchase we are talking about. What we need to find is the number of bags of snacks, so we need to find the value of Y. For that, we need to solve this system. We could do it algebraically using substitution or elimination, but the values here seem a bit cumbersome because we have values till 2 decimal digits. So instead, what we can do is solve this system graphically by plotting both these equations on Desmos and finding the point of intersection. So let's do that now. So in this Desmos graph, I have plotted the two equations. This red line here plots the equation 2.20x plus 1.95y is 18.55 for restaurant P, and this green line here plots 3.00x plus 1.5y is 19.50 for restaurant Q. And as we can see, the slopes of the two lines are different and they intersect in exactly one point, which is the point 4, 5. So 4, 5 is the solution of this system. And coming back to our problem, it means that X is, because the solution is 4, 5, X is 4, so the number of burgers in the purchase was 4, and Y is 5, the number of bags of snacks was 5. So the answer to our problem, how many bags of snacks, is 5. So that's it.